Hello students, this is Dr. Siva Nagaraju from IARE. Today we are going to discuss some solved problems on DSB. DSB means double sideband. So it is one of the variety of amplitude modulation. So in this session we are solving problems on DSB. So this topic will cover an analog and digital communications course, and this course consists of 6 COs. The first CO, which is outline the basic concepts of communication system, need of modulation and fundamental elements to realize amplitude modulation systems. So in module 1 covers amplitude modulation, DSB-SC, SSB-SC, VSB. So all these topics come under amplitude modulation systems. So all these topics will cover in module 1. Okay, now coming to the problems. So the first problem is a 4 GHz carrier is DSB-SC modulated by a low-pass message signal with a maximum frequency of 2 MHz. The resultant signal is to be ideally sampled. Calculate the minimum frequency of the sampling impulse track. So here the problem is regarding to the double sideband suppressor carrier. So before solving this problem, you must have an idea what is the DSB-SC signal and what is the amplitude modulated signal. So here the only difference between amplitude modulation and DSB-SC is carriers will going to suppress, whereas in amplitude modulation we are having the full carrier. So another name for amplitude modulation is a double sideband with full carrier. So in this case we are going to suppressing the carrier. So carrier is going to suppress. So here the wastage of power is going to reduce in DSB-SC. Okay. So what is the mathematical expression for DSB-SC? So just you are going to multiply the carrier signal with message signal, then you get the DSB-SC signal. So in this problem, the given the carrier is 4 GHz and FM is 2 MHz. So already you know that what is the modulation? Modulation means one of the carrier characteristic is varied in accordance with the instantaneous value of the message signal. And here we know that the message signal is a low frequency, whereas the carrier is a high frequency. Okay, so let us start the problem. So here AFC, the carrier frequency is 4 GHz. So we can write as 4000 MHz, and FM message signal is given as 2 MHz. So for DSB-SC signal we are having 2 sidebands. So the 2 sidebands, upper sideband and lower sideband, that is FC plus FM and FC minus FM. So the given FC as 4000 and FM as 2 MHz. So for the upper sideband you are going to add these 2 signals. So there is FC is 4000 MHz plus 2. that is 4002 megahertz. For FC minus FM, simply go to minus 4000 from 4000 megahertz to megahertz. So that is 3998 megahertz. So minimum sampling frequency should be is the Nyquist rate. So that is Fs is equal to 2 FM. So that is 2 into 2 megahertz. Okay. So here the bandwidth is given as 2 mega. So you taken as a minimum frequency as 4. So 2 into 4 is 8 megahertz. Okay. Coming to the second problem. A 400 watt carrier is modulated on a depth of 75%. Calculate the total power in the modulated wave in the following forms of AM. So one bit is DSB with full carrier and another bit is DSB with suppressed carrier. So already we discussed it. So DSB with full carrier is nothing but AM. Is nothing but AM. Okay. So here the given carrier power is 400 watt and another parameter is given as depth. So that is a depth of modulation 75%. So 75% means 7500 is given 0.75 mu as 0.75. So these are the given. Okay. So in this problem we are calculating the power. Total power in AM and power in DSB SC. Okay. So for this we require two formulas. One is PT, total power, is equal to PC into 1 plus mu square by 2. So PT is the total power for AM. For this AM, it is a double sideband with full carrier. So PC is the carrier power into 1 plus 0.75 whole square by 2. Why? Mu is given as 75%. So 75 by 100 is given as 0.75. So 0.75 whole square divided by 2. So by using calci, you getting the value is 512.5 watts. This is for AM. Power for AM. And the second bit is DSB SC. So here the suppressor carrier, for this the power is PC into mu square by 2. So you know the PC value, that is 400 watts into mu value 0.75 whole square divided by 2. So here you get 112.5 watts. So here you can conclude from this problem, the power required for DSBS is very much less than the AM. So that's why we are going to suppress the carrier. Okay. So coming to the third problem, a DSBS signal is generated using the carrier cos of omega ct plus theta and the modulating signal x of t. Find the envelope of DSB SC signal. So here the given carrier, signal is C of t, that is C of t is equal to cos omega ct plus theta, and modulating signal is m of t. They given as x of t here taken. So the DSB SC. So already you know the mathematical expression for DSB SC is just multiplying the message signal with the carrier signal. Okay. So S of t is the modulated signal. What is the modulated signal here? DSB SC. DSB SC modulated signal is the modulated signal S of t. So it is equal to C of t into M of t. That is equal to, here M of t is given as X of t and C of t is cos of omega ct plus theta. So here it is in the form of cos of omega ct plus theta is cos of A plus B. So cos A cos B minus sin A sin B. Here you are going to apply cos A cos B minus sin A sin B. So here cos theta cos omega ct minus x of t sin theta sin omega ct. That means here you are going to multiply x of t inside the brackets also. So finally the value is x of t cos theta into cos omega ct minus x of t sin theta into sin omega ct. So the envelope of the modulated signal is square root of x of t cos theta square plus x of t sin theta whole square. Okay, so this indicates the square. So square root of cos term plus square root of sin term. Okay, so finally what you got? You are going to take it as square root of x square of t into cos square theta plus sin square theta. So what you got? Cos square theta plus sin square theta? 1 it gives. And now this is square root of x square. So finally the value is x of t. Okay. So this is the third problem. And now another problem is, in an AM-SC system, modulating signal is a single tone sinusoidal 4 cos 2 pi to the 10 to the power of 3 t, which modulates a carrier signal 6 into cos 2 pi 10 to the power of 6 t. Write the equation of the modulated wave. So here they given M of t and C of t. M of t is message signal, C of t is carrier signal. So DSB SC is just you are multiplying the carrier signal with message signal. So C of t into M of t. So what is given C of t? Here C of t is equal to 6 cos 2 pi into 10 to the power of 6t. So here it includes the general expression for carrier signal is AC cos 2 pi FCT. 2 pi FCT. So here it includes the amplitude of the carrier and frequency of the carrier in C of t. Whereas in M of t, again AM cos 2 pi FMT. So AM is the message signal amplitude is 4 and FM is 10 Q. Okay. So here for the DSB signal, we are going to multiply C of t into M of t. So C of t is 6 cos 2 pi into 10 power 6t. Again M of t is 4 cos 2 pi 10 q t. So 6 into 4 get 24 and remaining is cos 2 pi 10 to the power of 6t into cos 2 pi 10 q t. So here using trigonometric relation, that is 2 cos A cos B, you can write it as cos of A plus B plus cos of A minus B. So using this trigonometric relation, we are going to expand. Okay. So the DSB signal is this one. 12 into cos 2 pi 1001 into 10 cube into t plus cos 2 pi 99 999 to the power of 10 cube t. Why? Here you are written as 2 cos A cos B as cos of A plus B plus cos of A minus B. Earlier we return this is 2 cos A cos B as cos of A plus B plus cos of A minus B. So here the terms A, B. So we are going to adding this A plus B and A minus B. So that's why here you get this value. So this is the equation what they ask. DSB SC signal. Okay. Now coming to the fifth problem. For the balanced ring modulator circuit, the carrier input frequency FC is equal to 500 kHz and modulating input signal frequency ranges from 0 to 5 kilo. Determine the output frequency range and output frequency for a single input frequency of 3.4 kilohertz. Okay, so this is a problem. So for this problem, we are going to solve by using given data. So what are the given data here? Here the given carrier frequency is FC. So FC is 500 kilohertz. And another one is modulating signal. So modulating means FM. So the modulating input signal frequency ranges from 0 to 5. So 5 kilohertz. So that's why the output frequency range. So 500 kilohertz minus 5. Yes, 495 kilohertz. And again 500 plus 5. So this is 505 kilohertz. So this is the frequency range. The output frequency range is 495 kilohertz to 505 kilohertz. And in the second time, here the input signal frequency changes as 3.4 kilohertz. Whereas previously it is 0 to 5 kilohertz. But in input signal frequency again changes as 3.4 kilohertz. So we can read it as a second bit, B bit in this problem. Okay. So the output frequency for single input frequency of 3.4 kilohertz. So here the FC is fixed one, that is 500 kilohertz. So again here 500 minus 3.4 to 500 plus 3.4 kilohertz. So that's why the output frequency for single input frequency of 3.4 kilohertz is this one, 496.6 kilohertz to 503.4 kilohertz. Okay. Oh, what here they ask? They ask just the input signal frequency is changing, but FC is same. Okay. And this is the spectrum, frequency spectrum for this one. Okay. So upper sideband, low sideband. Now the sixth one. Here the transmitter radiates 35 kilowatt when the modulation percentage is 85. Calculate the carrier power and the power of each sidebands. Okay. So here they given total power and percentage of modulation. Okay. So by using those two parameters, we are going to calculate the carrier power and the power of each sidebands. Okay. So let us solve what they given. Given P total is equal to 35 kilowatt and mu is 85%. So 85% means 85 by 100 you taken as 0.85. So now what is the formula for total power? P total is equal to PC into 1 plus mu square by 2. So they given the total power. What they asking? Find the carrier power. So I require this PC. So PC is equal to P total divided by 1 plus mu square by 2. This one. So what is my total power? 35 kilowatt. So 35 K divided by 1 plus mu 0.85 square divided by 2. So for solving this one, 35K divided by 1 plus 0.7225 divided by 2. So this one. So here calc is must. So by using this calc, we are getting the values. So 35K divided by, so this one you get your 2 plus taken LCM. So 2.7225 divided by 2. 2.7225 divided by 2. And finally, you get the total carrier power. Carrier power is 25.711 K. So this is my carrier power. So this is the carrier power for this one. And second one is power of each side bands. Okay. So here I am going to erase in this one. And again going to solve the second bit. Okay. So for this PC is over. So PC you get 25.71 K kilowatt. Okay. So power for the side bands is PC into mu square by 4. So this is the formula for the side band. So why they given? Calculate the carrier power and the power of each side bands. So for the formula for the side band power is PC into mu square by 4. So we know that PC value. So what is the PC value? 2.571 kilo into mu square 0.85 square divided by 4. So you are taking the 0.85 square divided by 4. Its value is 25.711 K into 0.1806. And finally, the sideband power is 4.64 kilowatt. So this is the sideband power. Okay. So one is the carrier power and another one is the sideband power. Okay. Coming to the seventh problem. So in this problem, a carrier wave with amplitude 29 volts and the frequency 10.5 megahertz is amplitude modulated to 50% level with a modulating frequency 1 kilohertz. So given an expression for the above wave and also sketch the waveform in frequency domain. So here they given as a wave. Okay. So this is like a carrier wave. So the carrier having 29 volts and this is the frequency. Here the total frequency is 10.5 megahertz. So this is a carrier signal. Okay. So the general expression for this amplitude modulated wave. Here wave means amplitude modulated wave. Above wave means amplitude modulated wave. Okay. So the first you are going to write the given values. Okay, so it is very, very important when you're solving a problem. First write the given data. Okay, so AC is 29 volts and FC is 10.5 megahertz and mu is 50%. So 50% means 50 by 100 is again 0.5, and FM modulating signal frequency is 1 kilohertz. So this is a given data. Okay, for this data here we are going to solve the problem. Okay, so first write the expression for the ambient modulation wave. So here S of t is the modulated signal, that is AC into 1 plus mu cos omega mt, or you can write your 2 pi fmt, whatever it may be. Okay, so 2 pi fmt into cos 2 pi fct. Okay, so here you can substitute the values in the given expression, then you get the full expression for this a given amplitude modulated wave. Okay, so here the given FM, the given FC. So for the inner side brackets you get your 2 pi FM. So FM is 1 kilo where FC is 10.5 mega. Okay, so for this S of t is equal to AC 29 into 1 plus, what is my mu? 0.5 into cos 2 pi fmt. So 2 pi fm. So pi value is again 3.14. So you go to multiply, then you get this value is 6283.2 t, 1 kilo. So that 1 kilo is going to multiply here. So in this expression inside the brackets is 1 plus 0.5 cos 6283.2 t, and out of the brackets is cos 2 pi fct. So fc is 10.5 mega. So here you go to multiply this fc is again 10.5 into 2 pi. Okay, so finally you got 65.97 into 10 power 6. Why? Here the FC is in megahertz, so that's why here cos 65.97 into 10 power 6 t. Okay, so this is my expression for the first bit in this problem. The first bit is given expression. By using all the given data, I am going to substitute all the values in the expression. So here you must remember this formula for amplitude modulation. Okay, or DSB, what it may be. Okay, from coming to the next bit here, and also sketch the waveform in frequency domain. So here we are going to draw the frequency spectrum. So frequency domain means you are going to draw the spectrum. Okay, so for the spectrum, what we required? We required upper sideband and lower sideband. So first you go to find the sidebands. Okay, for that, so here I am going to erasing all this one. Okay, now to find F USB and F LSB, frequency of upper sideband and frequency of lower sideband. So we know that USB is nothing but FC plus FM, where LSB is nothing but FC minus FM. Okay, so for that F USB is equal to FC plus FM. So what is FC? 10.5 mega. That means 10 power 6 plus FM. FM value is 1 kilo. So 10 cube. Okay, 1 into 10 cube. So then F USB is equal to 10.501 into 10 power 6 hertz. Why? Because one is in megahertz and another one is in kilohertz. Okay, so 10.501 indicates this one is in kilos. Okay, so that's why 10 power 6 hertz. Okay, and for FLSB, that is equal to FC minus FM, that is equal to 10.5 into 10 power 6 minus 10 cube. Okay, so here you go to subtract. So FLSB is equal to 10.499. Why here you get it as 500? So 10.500, here 0.001. So you got 10.499 megahertz. Okay, and here what is required to draw this frequency domain? Amplitude also required. So for the amplitude of the sideband is required amplitude for this amplitude mu AC by 2. Mu AC by 2. So we know that mu value is 0.5 and AC value is 29. So 0.5 into 29 divided by 2. So 0.5 29 divided by 2. So you got 7.25 volts. So this is my sideband, amplitude of sidebands. So now we are ready to draw the waveform. That means frequency domain. So this one is FC. So FC amplitude is 29 volts. Okay, and another is 2 sidebands. They are just like this. So its amplitude is 7.25 volts. Okay, and here one is FC plus FM, one is FC minus FM. So what is FC? 10.5 megahertz and FLSB is 10.501 megahertz and LSB is 10.499 megahertz. So this is the given problem. Okay, so in this problem they ask first bit is expression of the wave and second one is sketch the waveform in frequency domain. Okay, so coming to the 8th problem. Yeah, so here calculate the percentage power saving when the carrier and one of the sideband are suppressed in an AM wave modulated to a depth of 100% and 50%. So here the given mu values 2, mu1 and mu2. Mu1 is 1, 100%, and one is 0.5. Okay, so by using this given data we are going to find or calculate the percentage power. Okay, solution. So what you required formula, that is P DSB SC is equal to PC into 1 plus mu square by 2. So this is the required formula for the first one. Okay. So here the given mu is 100%. So first one you taken as mu is 100%. So its value is 1. So here directly you can substitute mu value is 1. What you got? Its value is 1.5. Why? 1 plus mu square, 1 square, 1 by 2. Okay. So its value is 1.5. So P DSB SC is equal to 1.5 PC. Okay. So next one is power required for single suppressed carrier transmission is given by, it is PSSB PC into mu square by 4, mu square by 4. So again here mu value is 1. So 1 square is 1. So into PC divided by 4. So 1 by 4 is 0.25. So therefore PSB is 0.25 PC. Okay. And now how much power is saved? How much power? Okay. So therefore percentage of power saving when mu equal to 100%, that means 2 times here we have to calculate. For the first time 100% percentage, and second time is 50%. How much power is saved? Okay. So let us start with the first one. Therefore percentage of power saving when mu is equal to 100%. That is one is percentage of P saving is equal to DSB SC minus P SSB divided by P DSB SC into 100%. Okay. So here you calculated power of DSB SC and power of SSB. So we are going to how much power is saved when mu is 100%. Okay. So what is PDSB? That is 1.5 PC minus 0.25 PC divided by 1.5 PC into 100 into 100. So you can take common PCs, simply you could cancel. So 1.5 minus 0.25 divided by 1.5. So by using calci, you get percentage of power saving is 83.33%. So this is for mu equal to 100%. So mu value is 1. Okay. So for the second bit, that is 50%. Okay. So for the second bit, here mu is, so for second bit mu equal to 50% is equal to 0.5. So again you go to calculate the same formula. PDSB is equal to PC into mu square by 2. This first one we taken and substitute. Therefore P DSB SC is equal to PC into 1 plus 0.5 whole square. Okay. So that is 0.25 divided by 2. So this is power in DSB-SC when mu equal to 0.5. Okay. Mu equal to 0.5. And when you go to taken again LCM 2 plus 0.25 divided by 2. So it is 2.25 divided by 2. So simply get 1.125 nearly. Therefore DSB SC is equal to 1.125 PC. So this is the first case, PDSB SC. And for the second case, that is PSSB. Okay, so PSSB is equal to again PC into mu square. Here mu is 0.5. So 0.25 0.5 square, that is 0.25. So 0.25 divided by 4. 0.5. Okay. So its value is again 0.0625 PC. So this is PSSB. And second one is also. Now again we are going to calculate the percentage of power saving. Okay. So same formula, that is power saving is equal to DSB SC minus power of SSB divided by power of DSB SC into 100. Okay. So for we are going to calculate taking these values. DSB SC is 1.125 PC and P of SSB is 0.0625 PC. Okay. So this is mu equal to 0.5 for this one, and this is for mu equal to 1. Okay. So for this, again percentage of power saving is equal to power of DSB SC minus power of SSB divided by power of DSB SC into 100. So what the power of DSB SC is 1.125 PC here we taken. So this value is 1.125 PC minus 0.0625 PC divided by 1.125 PC, this one, into 100. So this is a percentage of power saving. Okay. So again here also you can take in common this PC and denominator also PC. So simply you can take it as minus. So here one more step, 1.25 minus 0.0625 into PC divided by 1.125 PC into 100. So this is going to cancel. So therefore percentage of power saving is equal to you get 1.0625 divided by 1.125. So you get nearly 94.44%. So this is power saved. This much power is going to save. Okay. So the ninth problem is the output current of 75% modulated AM generator is 1.5 amps. So in the problem, they given A bit and B bit. So in the A bit, to what value will this current rise if the generator is modulated additionally by another audio wave whose modulation index is 0.6. Again B bit, what will be the percentage power saving if the carrier and one of the sidebands are now suppressed? So in the ninth problem, the given data is mu is 75%. So it is 0.75 mu value is. Okay. And the given current. Whereas in previous problems, we are dealing with the power relations. But here, we are taking the current relation. So based on the current relation, we are going to find the values of this problem. Okay. So let us start the solution. So first I am going to write the current relation IC is equal to IT by square root of 1 plus mu square by 2. So here the mu is given. The mu is 0.75. So that's why here we are going to substitute the mu value. And IT value is 1.5. So here 1.5 divided by square root of 1 plus mu 0.75 square by 2. So by using calci, go to calculate this numerical value. You get this IC value is 1.325 amps. So this is my IC. But in the first bit, here you can see the first bit, to what value this current rise if the generator is modulated additionally by another audio wave whose modulation index is 0.6. Initially the given mu value is 0.75 and again it changes to 0.6, and here we are taking another modulation index. So what is a total modulation index? When you have taken two modulation indexes, one is mu1 and another is mu2. So here also a small formula is there, that is mu of t is equal to square root of mu1 square plus mu2 square and so on. If you can add more number of modulation indexes. Okay, so here initially my mu1 is 0.75 and secondly they given additional one is 0.6. So I am going to add these two modulation indexes and getting the total modulation index. Okay, so here I am going to substitute this 0.75 square plus 0.6 square. So for 0.75 you get 0.5625 plus 0.6 square, it is 0.36. So you get 0.9225. So this is my mu t, total modulation index. When applying the square root for this 0.9225, you get the mu of t value as 0.9604. So this is the modulation index. So for this modulation index, you are going to find the total current. Why? Here I get the IC value is 1.325 amps. By using this IC value, I am going to find my total current after the adding the two modulation indexes. So IT, the total current is equal to IC into square root of 1 plus mu square by 2. So this is the formula. So here we know that IC value is 1.325 into 1 plus square root of 1 plus mu value is 0.9604 square divided by 2. So again by using calci, you get this total current IT value as 1.601 amps. Okay, so this is for A bit, solution of the A bit. And second one, B bit is there. Here in the B bit, they asked how much power is saving for two sidebands and with the single sideband. Okay, so for B bit, to find percentage of power saving, so here taken P total is equal to PC plus PC into mu square by 4 plus PC into mu square by 4. So here what here the given, the total power is contributed by the carrier power and the two side bands. So here the 2 sidebands. So this is the AM. So carrier plus 2 sidebands. So here to find the percentage of power saving, if carrier and one of the sideband is suppressed, we have the total power P total is equal to PC plus PC mu square by 4 divided by this total power, that is PC plus PC mu square by 4 plus PC mu square by 4 into 100 into 100. So here we get the total power saving. Okay, so in this expression I can take common from the numerator, that is 1 plus mu square by 4 divided by PC, again 1 plus mu square by 4 plus mu square by 4, that is 2 mu square by 4. So 2 mu square by 4 means mu square by 2. Mu square by 2 into 100%. So here what my mu value? So after getting those two modulation indexes, mu1 and mu2, you get the mu value is mu value is 0.9604. So here I am going to substitute this 0.9604 in this expression. So here the PC is going to cancel. So 1 plus 0.9604 square divided by 4 divided by 1 plus 0.9604 square by 2 into 100. So finally here, by solving all these numerical values, you get the total power saving is 84.2%. So this is the solution for the 9th one. Now we go for the 10th one. So in the 10th problem, they given an audio frequency signal 21 sine 2 pi 400t is used to amplitude modulate a carrier of 27 sine 2 pi 10 to the power of 4t, assuming modulation index of 0.3. Calculate sideband frequencies, amplitude of each sideband frequencies, total power delivered to the load of 450 ohms, and the dB is bandwidth required. So this is the given problem. In this given problem, here audio frequency signal means nothing but our message signal M of t, and another one is a given carrier. So carrier is given C of t and M of t is given, and mu value is 0.3. Okay, so for this problem, first you go to return the given data. So here first, what is the given data? Given in the first line, the given sine 2 pi 400t. What that one is nothing but am sine omega mt. So am sine omega mt. What is one? This is nothing but my message signal, and another is carrier signal. C of t is equal to AC sine omega ct. So this is my message and this is my carrier. So by using this, omega m is equal to 2 pi 400. So what is omega m? Angular frequency. That is nothing but 2 pi fm. So 2 pi 400. So this 2 pi going to cancel. You get omega m equal to 400 hertz. Similarly, omega c is equal to 2 pi 10 to the power of 4. So again, omega is equal to 2 pi fc, that is equal to 2 pi into 10 power 4. So 2 pi is cancelled. So fc is equal to 10 to the power of 4 hertz or 10 kilohertz. You can return. Okay, and another what they given, am is nothing but 21 AC is nothing equal to 27, and finally the mu modulation index is equal to 0.3. So these are the given data from this problem. Okay. So after getting all the data, we are going to solve the problem. So let us go to the solution. So for the solution, what they ask first? Sideband frequencies. A bit is sideband frequencies. What is the sideband frequency? Here you are having two sidebands. One is upper sideband and another is a lower sideband. So for upper sideband frequency, for upper sideband is equal to FC plus FM. What is FC? Carrier frequency. What is FM? Message frequency. So one is 10 to the power of 4 plus another is the 400 hertz. So one is 10 kilo, another is 400 hertz. So finally my upper sideband frequency is equal to 10.4 kilohertz. Okay, and another is my lower sideband, that is FC minus FM. So nothing but 10 to the power of 4 minus 400 hertz. So one is 10 kilo. So 10 kilo minus 400 hertz. So it is nothing but 9600 hertz, or simply 9.6 kilo. Okay. So this is my sideband frequencies. And what is B bit? B bit is amplitude of each sideband frequencies. So this is my B bit, amplitude of each sideband frequencies. For this, mu AC by 2. Mu AC by 2. We know the mu value. What is the mu value? It is nothing but 0.3 into AC 27 divided by 2. Okay. So solving this, you get 4.05 volts. So this is the amplitude of each sideband. And next one is the total power delivered into the load. Okay. So for the C bit, PT is equal to, actually it is PC, but in the place of PC we are taken as AC square by 2R into 1 plus mu square by 2. What is generally PT is equal to PC into 1 plus mu square by 2. So this is the general expression for AM power calculation. Okay. But in the place of PC, they are given as AC square by 2R. Okay. So here they given R value. We know that AC value. We know the mu value. So just you go to substitute the values in this expression. Okay. So AC is 27 whole square divided by 2 into 450 into 1 plus mu square. Mu value is 0.3 square divided by 2. Okay. So for this, 729 divided by 900 into 2.09 divided by 2. Okay. So why 0.3 square is 0.09. So taking LCM, 2 plus 0.09 divided by 2. So 2.09 divided by 2. So after solving all this, you get this value is 0.84 watts. So this is C bit. And we go for the D bit. So D bit is bandwidth required. So how much bandwidth is required? So for that, you can take in the bandwidth is equal to F USB minus F LSB. So what is my USB frequency? Is nothing but 10.4 kilohertz. What is my LSB? 9.6 kilohertz. So you get 800 hertz. So this is the bandwidth for the dBit. Okay. Now coming to the 11th problem. So in this problem, the total power content of an AM signal is 1000 watt. Determine the power being transmitted at the carrier frequency and at each of the sidebands when the percentage of modulation is 100. So here they given power. They given total power 100 watts and they given mu value. Mu is 100 means 1. Okay. So for the total power content. Okay. So here you can write the given data first. So given data is PT is 1000 watt and M equal to 1. Okay. So this is the given one. So for which signal we are going to find this power? AM signal. Okay. So let us start the solution. So the total power is equal to PC plus P USB plus P LSB. Similar to the previous one. The total power is contributed by the carrier, upper sideband and lower sideband. So PC plus there is a mu square PC by 4 plus mu square PC by 4. So PT is equal to here PC plus mu square by 4 plus mu square by 4 gives 2 mu square by 4. So 2 times you go to cancel the denominator. So mu square PC by 2 we got. Okay. So here you substitute a mu value. What is mu? 1. Okay. So here again you take in common this PC. So PC you can take common 1 plus mu square by 2 and mu value is 1. Then here this is 1.5 PC. So PT is equal to 1.5 PC. So now what is the total power? Total power is 1000 watts. So 1000 watts into 1.5 PC. But I required PC. So 1000 divided by 1.5 gives 666.67 watts. Okay. Now PT minus PC, that is equal to 1000 minus 666.67. It gives 333.33 watts. But for individual sidebands, PUSB is equal to PLSB is equal to this 333.33 divided by 2 gives 166.67 watts. So this is the solution for the given problem. Okay. Now this is the 12th one. So in this 12th problem, the baseband signal M of t is recovered from the DSB signal. S of t is M of t into cos 2 pi FCT. So this is my DSB signal here. This DSB signal is multiplied by the locally generated carrier. So this is my carrier. Cos 2 pi FCT plus pi. This total product is passed through LPF, which rejects the double frequency signal. Already we know that LPF, which allows the low frequency signal only, and it detonates or rejects high frequency signal. Okay. So this problem is based on the detection. Okay. So what is the maximum allowable value for the phase angle if the recovered signal is to be 95% of the maximum possible output? Okay. So if the baseband signal is band limited to 10 kHz, what is the minimum value of Fc for which m of t can be recovered by filtering? Okay, so this is the given problem. We are going to solve this one. So first, the product signal. Why? The DSB signal is multiplied with the carrier. Okay, so we are called the product signal. The product signal is S of naught of t. So S of t is multiplied with cos 2 pi fct plus theta. Okay, so what is S of t? S of t is nothing but DSB signal. So that what is DSB? It is nothing but m of t cos 2 pi fct into cos 2 pi fct plus theta. Okay, so this is the product. So this product which is passing through the LPF. So here you can see two cos terms. So we can call as a cos A cos B simply. So cos A cos B, when you get cos of A plus B plus cos of A minus B, you get this. So here 1 by 2 of cos of A plus B plus cos of A minus B. So here you can treat it as a term, this is B term. So A plus B. So 2 pi fct plus 2 pi fct. What you got? 4 pi fct. That means one term having 4 pi fct. And the second term which having m of t into cos 2 pi cos 2 pi theta. Okay, sorry, cos theta, simply cos theta. 1 by 2, here two terms you are getting. Why? This is cos A, cos B. So 1 by 2, m of t by 2 into cos of A plus B plus cos of A minus B term. Okay, so A plus B means here you are getting 4 pi fct term. First term. The second term, you are having only cos theta term. Okay, so this total product will passing through the LPF. What is the LPF duty? LPF which rejects the high frequency term. So the first term is high frequency. Here high frequency term is there, 4 pi fct. So this 4 pi fct is going to eliminated by the LPF. So what is passing here? Only this 1 by 2 m of t cos theta is passed through the LPF. Okay. Now what they are asking? The maximum allowable value of theta. So here the maximum allowable value. So what is the theta value? Can be, you go to calculate it. Okay. So for this 1 by 2 m of t cos theta divided by maximum allowable of theta value cos theta, which is equal to 0.95. So this is the new value. So for equating this one, you are getting theta is equal to cos inverse 0.95. Then you get 18.19 degrees. So this is the maximum allowable theta value. Okay. So another bit is here what the minimum value of Fc. So for this filtering method, here they considered 2 Fc minus 10 kilohertz greater than 10 kilohertz. So here you can send this other side is 20. So 2 Fc equal to 20. So Fc is greater than 10 kilohertz. So the minimum value of Fc is nothing but 10 kilohertz. So here we are going to recover this m of t by filter method. So the lowest frequency value is 10 kilohertz. Okay. So these are the solved problems in DSB and AM. Okay. So taking the reference from information of Simon Hacking here. The content of information is taken from Communications by Simon Hacking, 3rd edition, 2nd edition, okay, and Analog and Digital Communications by Simon Hacking, okay. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.